Hi, in this video I'm going to show you how to use a tree diagram to answer probability question as the question above. You have been handed a bag containing 4 $1 bills and 2 $5 bills. You will reach in the bag blindly and select 2 bills at random. Sketch a complete tree diagram to represent the outcomes of this random selection. And then we will answer the following questions. What is the probability that you end up with $6? And the second question is, what is the probability that 2 selected bills are the same dollar amount? So one way you could answer this question is to make a tree diagram. So first let's take a look and annotate. It says we have 4 $1 bills and we have 2 $5 bills. So it's important to see the total amount. So our total sample size is 6. What would be the probability of selecting $1 bill? We can already see that there's 4 $1 bills, so it would be 4 out of 6. And then if we wanted to select a $5 bill, it would be 2 of them, so 2 out of 6. So we start off with the probability of picking $1 is 4/6, and the probability of picking $5 is 2/6. But then we're going to pick another one. So the best way to represent this is with a tree diagram. I'm going to draw it horizontally. I'm going to state the probability of picking $1, and I'm going to always have $1 going up. So I will say that that is, we already stated, 4 out of 6. But then we can select the first bill as $5. I'll do that in blue. The first time we select, we can either pick $1 or $5. So the probability of selecting $5 is 2 out of 6. We're going to pick our second bill. For the first one, I'm going to create branches. So the next outcome that could happen is my second bill could be another $1 bill. So what I'm going to call this using probability notation, what's the probability of picking $1 given, this means given that we already picked $1 here. So let's think about it. We already picked $1. In other words, out of our total amount, there's now going to be a total of 5, but we also already picked $1. So that means there's going to be 1 less than 4. So that will be 3/5. The next outcome that could possibly happen if we don't pick a dollar, we can say that we picked $5 here. So I'm going to write it as, what is the probability of picking $5 given, this means given, that we already picked $1. If we already picked $1, then I know I have out of 5 to pick, but we have not picked any of the $5 bills, so that would be 2 out of 5. Now, one thing I want to mention is that picking $1 or picking $5 are mutually exclusive because it's either $1 bill or either $5 bill. Notice that the total amount here adds up to 100%. In other words, the first time I pick a bill, it's either 4 out of 6 or 2 out of 6, and if you add it together, the total outcomes are 6 out of 6. And if you look at the above here, the next time I pick a bill, it could either be another $1 or it could be the first $5. And the total outcomes of that is 5 out of 5, which is 100%. So every time you're drawing a tree diagram, every first branch is going to be mutually exclusive and it's going to add up to 100% of your outcomes. So I'm going to go ahead and show the other possibility. What if we would have picked a $5 bill at first? Then, as I mentioned before, I'm going to go up my branch for $1. Then the second bill could be a $1. But what I'm going to write here is what is the probability of picking $1 given that we already picked $5. So right here, we already picked $5. What would that be? Well, if we already picked $5, then that means I would have 1 less again for my total sample size. So it would be out of 5. But since we picked $5, it would be, and now I'm picking $1 for the first time. So it would be 4 out of 5. All right, the next and the last one is what would be the probability of picking $5? So in other words, this would be the second time I pick $5, given that we picked $5 the first time. If I have 4 out of 5 here and you guess this would be 1 out of 5, you are right because we already picked one of the $5 bills. So we would have a total of 5 left, but there were only 2 $5 bills. So the last outcome would be 1 out of 5. All right, so here is our tree diagram, but we are not done yet. What we want to do is, once we have drawn our tree diagram, is you can multiply the probabilities. So in other words, I would multiply 4, 6. I would follow along this path. This path means picking $1 and then picking a second bill, $1 again. So I'm going to leave the fractions and multiply, because probabilities multiply each other. So the first time I picked $1 is 4, 6. And then the second time I picked $1, that is 3/5. And if we multiply that across, I'm going to say 12 out of 30. I'm going to leave this as a fraction right now, because when we finish our last tree branch, our total outcome should add up to 100%. All right, so let's look at the next one. This one is 4 out of 6 times 2 out of 5. Applying across will give us 8 out of 30. And on the bottom, I'm going to multiply 2, 6 times 4/5. And that would mean I picked $5 the first time and I picked $1 the next time. Multiplying that across, that would give us 8 out of 30 again. And for the last branch, we have, I'm going to follow the last branch here. So it's 2, 6 times 1/5. And I'm going to write that down here. That would give us 2 out of 30. You know you did this correctly if I'm going to add up all my total outcomes. So this represents all the total possibilities, and if it adds up to 1 or 100%, then you know that you have your total outcome. So let's add it up. 12 and 8 is 20, 28 and 30. This represents 30 out of 30, so we have our 100% of our outcome. Now that we have the tree diagram, we can easily answer the question, what is the probability that you end up with $6? Well, all you need to do is look across the branches, and I'm going to highlight where $6 is. So this represents picking $1 the first time. That would mean I follow this path, and then this represents picking $5 the second time. 8 out of 30 is $6 because I have $1 and $5. Remember, this means given I picked $1 in the beginning. All right, the next $6 that we also have is we pick $5 and then we would need to pick $1, which represents this following path right here. So we picked $1 and we have $5. So we go along this and we have 8 out of 30. The probability that you end up with $6 is just 8 out of 30 plus 8 out of 30, because there's two ways that could happen. You could pick $1 first and then $5 second, or you could pick $5 first and $1 second. So that would give us 16 out of 30, and that reduces to 8 out of 15. And if you calculate that on a calculator, 8 out of 15 is approximately 53.3%. All right, let's answer the last question. What is the probability that the two selected bills are the same dollar amount? Well, same dollar amount means I either picked $1 then $1 the second time, or I picked $5 and then $5 the second time. We can see that this means $1, and then I picked the second time $1 here. If I follow this branch right here, that gives us 12 out of 30. And then we're going to look to see where is $5 and $5. That would mean first time I picked $5 here, follow the branch. The second time I picked $5 here. So that would give us 2 out of 30. Probability of picking $5 and then $5 again is 2 out of 30. We add the probability of picking $1 bill and then $1 bill. Our total is 14 out of 30, be 7 out of 15, which would mean 46.7%. So there you go. This completes an example of how you can use a tree diagram to solve probability questions. Hopefully it wasn't too bad.